Okay, so now that we have covered some of the basics, let's begin with the design exploration. With the results on, let's switch to von Mises stress in megapascals. Let's open the default max von Mises stress monitor as well. Notice that I reverted to structural steel as the mount material. Let's also remove all previous design results by right-clicking and selecting Remove All Previous Runs. Lastly, let's delete the scene we saved by right-clicking and selecting Delete. Let's reorient the home view, zoom in, and save a scene of our starting point, and rename it as such. Now that we have a clean slate, let's look at the results. For this case study, we'll be focusing on this stress peak between the support wall and the reinforcement wall. Let's assume this area is highly susceptible to failure, and we'll need to take a look at a few design changes aimed at reducing this peak stress. First, let's create a monitor for those two edges to track them independently. Let's click on Monitors, select the two rounds, and choose von Mises stress. We'll want to monitor the maximum value. Click Accept or hit Enter. We'll now be able to see the newly created monitor. Let's go ahead and rename it as Local Stress. Now, let's switch to our Design tab. Most design changes can be performed with the Pull, Move, and Fill tools. Let's use the Pull tool to increase the radius at the peak stress. Click on the Pull button or enter P. There are various ways to pull geometry, and in our case, we'll use it to change the round diameter. To do so, select the two round and update the value to 6 mm. You can pull outwards to increase the radius or hit space and enter 6. The results will start to auto-update, and once complete, the second design point will appear in the monitor. We can see the stress has improved. Let's save a scene as Stress Radius Change. Reorient to the home view and zoom in. So now we can test out another idea. We can move the supports in the aft direction and check how that affects the stress. To do so, select the rounds, the lug ends, and the attachment holes. Now click on the Move button or enter M. In this case, we can simply click on the arrow pointed in the aft direction and move it out or hit space and enter a value. In this case, we'll enter a value of -20 mm. Note that you can reorient the move coordinate system by holding Alt and selecting a geometry to align to. We can see that the stress improved again. Let's save a scene as Stress Support Shift. Reorient to the home view and zoom in. We can also thicken the walls to add more material to the cross-section. We can enable the Pull tool again and select the inner faces of the two support vertical walls. Note that if geometry is not visible, you can access it by holding Ctrl and scrolling through the geometry behind the visible one. Now, let's thicken the walls by 6 mm. We can see that the stress continues to improve. Let's save a scene as Stress Thicker Walls. Reorient to the home view and zoom in. Let's explore one more idea, and we can then move on to a different objective. Let's add a second pair of walls under the hinge support. Before beginning this, let's pause the solver to ensure any intermediate steps are not monitored. Now, double-click on the face of each wall to extend the selection to all faces on the walls. Now bring up the Move tool and click on the arrow pointed towards the aft direction. Hold Ctrl and drag a new wall between the holes on the outer walls and the lower bolt cutout. Now, we can specify the positioning of these new walls by measuring their distance from a reference point. We'll do this by using the ruler button in the HUD. Note that we must have a specific direction specified, as we do in this case, for the ruler to be accessible. Let's assign a distance of 65 mm between the original walls and the new ones. To do this, Let's reset our Move tool by hitting Escape or clicking on empty space. Now, let's select the two new walls and drag the local Move coordinate system towards the forward face of one of the new walls. This will ensure that we measure from this face to the reference point. Now, click on the arrow pointing forward and then on the ruler. You can now select the reference point. We'll select the closest face on the original wall. We can now specify this measurement, which will be 65 mm in our case. We can resume our solver and check how this change affects the results in our monitor. And let's save a scene as Stress Added Walls. Reorient to the home view and zoom in.